So, the thing about the rolling enemy is that it's going to start in one side where the camera can actually see the enemy, and it's going to roll to the other side. Once he reaches the other side, it's going to move to another position in the z-axis. Okay, so there's going to be some depth involved here, and then it's going to roll again to the other side. That's pretty much how it's going to work. So to start working with this, we just want to make the enemy to roll to one side. Okay, so let's move it to this position, so it's going to be barely visible by the camera. So here, okay, or let me move it closer to the floor, and then here. And we can see the enemy, and once it stays there, it's going to wait for just a little bit and then move to the other side. Okay, so let's go ahead and start with the basics. We're going to open the script for the rolling enemy. So scripts, enemies, then rolling enemy, and here we want to give it a movement velocity. Okay, so a speed. I'm going to type here public float speed. Okay. And also we want to define a certain limit, so once it reaches that position, that limit, it's going to switch sides. So public float, and let's use a name similar to what we did with the jumping enemy. Okay, in the jumping enemy we have that horizontal range, so let's use that as well. So public float horizontal range, and let's set that to be 4F as well. Okay, and in the update method, let's make it simply move to the left side. So in update, we're going to type transform, or even that's not actually needed. We can type straight get component of type rigid body. We open and close parenthesis dot velocity equals 2. And a very simple way to write this is to type vector3 dot left multiplied by speed. Okay, vector3.left is shorthand for -1, 0, 0, so it points to the left. And since we multiply it by speed, it's going to be the speed that we use, so minus the speed, 0, 0. So let's save this and give this a try. Okay, we go to Unity, we wait for the compilation to be finished, and once that's done, we're going to press play. Okay, and as we press play, you notice that's still not exactly moving, but the speed is set to 0. So if you use 1, it's going to roll to the left. If we use 4, it's going to run on a faster speed. So let's go ahead and define that as 4. Okay, we're going to save this. And to test this in an easier way while the enemy is not killing the player, let's move it here, okay, further down in the z-axis. Now let's press play again, and the enemy is going to be here, and it's going to be rolling to the other side. Okay, and by the way, you notice that it was floating before actually rolling. Okay, it fell very slowly in the vertical axis. This is happening because of how we set the velocity. When we do this, we are setting in almost every frame that the velocity on the y-axis is going to be 0. So a better way, a more consistent way to do this is to type new vector3, and we're going to manually build the velocity vector for it. So x is going to be minus speed, y it's going to be whatever we have in y, so we can copy this, the get component, and then velocity, and then we type dot y, and we can also replicate whatever we have in z. So we paste that again, dot z. So we only change the velocity in the x-axis. So now we save this, we go to Unity, we wait for the compilation to be finished, and now we are going to press play. Okay, so our enemy is going to roll to the left, which is exactly what we want. Okay, perfect. But now we want when it reaches the other side to switch back, moving to the right. Okay, we don't want it to be moving only to one side and then disappearing forever. So we're going to need a few variables to help us do this. We're going to type here private, then we're going to type bool, and then we're going to start by typing moving left, for example. Okay, and moving left is going to start as false, but by default let's set it to be true. Okay, in the start method we type moving left equals to true. Okay, perfect. And now that we have this in the update method, we need to make this a little smarter than it is right now. Here we use minus speed, but what we actually want to do is we want to check if we are moving left. If we are moving left, then in fact we're going to use minus speed. But if that's not the case, we're going to use only positive speed, so it moves to the right side. So we can use a ternary operator to do this in a very simple way. Here we're going to type moving left, then a question mark. If that's true, we use minus speed. Else, so we add a colon here, we're going to use speed. Okay, and this is just enough for making the player to move left and right. What we must do now is we want to check if the rolling enemy reached one of the horizontal ranges where it is right now. Okay, and if it does, we want to swap the value in moving speed. So to do this, let's add a few comments first. So make the enemy move. And here we're going to type check for direction change. So what we want to do is if moving left, okay, and we want to also check if its X position is after the range, okay, so if it should flip. So we can add two ampersand characters, as this is an AND. We're going to check if transform.position.x is lesser than minus horizontal range. Okay, now we close that, we open and close curly braces. If whatever we put here is true, that means we have to switch the value for moving left. And there is one extensive way to do this, and there is a very simple way to do this. One of the ways is we want to do if moving left equals to true, then we can type moving left equals to false. Else, then we type moving left equals to true. So make sure you understand this before we move to the simple way. So if moving left is true and we set it to false, it means that it's going to move to the right. If this is false and it's moving to the right, then it means it's going to move left. But what we want to do here in a much simpler way to avoid any code duplication, we can simply type moving left equals to not, so an exclamation sign, moving left. So it's going to switch. Okay, and now that we have this, we can make another case. So we can type else if. Then we can type here not moving left. So that means if moving left is false, so it's moving to the right, and transform.position.x is greater than horizontal range. Okay, so this is the right limit of this game. Then we do the same thing. Moving left equals to not moving left. It's going to have pretty much the same effect. So if we save this and go to Unity and wait for the compilation to be finished, we can once again press play, and we're going to see our enemy rolling to the left. If it reaches the other side, it moves to the right, and it's going to be rotating like this. And there is another way we can write this logic here. Okay, and there is an even cleaner way to type this. Okay, as you see, the outcome for both these checks is still the same thing. Moving left equals to not moving left. Moving left equals to not moving left. So we can bundle everything in the same check. So what we can do here is we're going to put all of this between parentheses. We're going to add two vertical bars for the OR operation. And here we're going to open and close parentheses, and we're going to copy this verification here. Okay, so I can copy this here and paste it here. Okay, and we're going to remove this else if. So what is happening here? We are checking two things at once. We are checking if either we are moving left and we left the left limit, and if we exited through the left limit, or if we are moving right and we reached the right limit. Okay, if either of these is true, then we simply set moving left equals to not moving left. So we can go to Unity, wait for this to be finished, and now we need to press the play button. So the enemy is going to move to the left, then move to the right. It's the exact same thing as we did before, so this is going to work exactly as we want. And now that we do this, we need to make a little waiting time for the rolling enemy. Okay, so once it reaches one of the sides, it's going to wait, 2 seconds before moving to the other side again. Okay, so we want to make here a public float wait duration. Okay, this is something that we're going to define. Let's type 2f by default, and then we're going to tune this. And we're also going to add here a private float waiting timer. Okay, so what's going to happen? Once we switch the positions, we want the enemy to wait a little bit before moving again to the other side. So here we're going to type waiting timer equals to waiting, let me check here, to wait duration. Okay, let's change this to waiting as well. It's going to be waiting duration. Okay, so this is going to work as a timer, as a countdown clock. Okay, and what we want to do here is there's something that we need to check. We need to check if waiting timer is greater than 0. why we need to check this? Because if it's greater than 0, then the player shouldn't move. If it's equal or if it's lesser than 0, that means the player already, the enemy already waited long enough, and then it can move. So in this else block, we're going to cut this enemy move logic and put here. Okay, so if waiting timer is lesser or equal than 0, then make the enemy move. But if it's greater than 0, then we're going to make the enemy wait. Okay, and to wait, we're going to type get component of type rigid body dot velocity equals to, then we can type more or less the same thing that we did here for the vector 3, but as this enemy is not going to jump, we can keep things simple. We can just type vector 3 dot 0. Okay, and I think later we can even make this a bit cleaner than it is right now. And the other important thing to do is, in the update method, at all times, we need to decrease whatever is here in waiting timer. Even if it's 0, okay, we need to make it count down, okay? So here, actually we can put it here inside the waiting timer, okay? We can put here, if waiting timer is greater than 0, we type waiting timer minus equals time dot delta time. Like this, okay? And as I told you a few times, time.delta time is going to return how many seconds have passed since the last frame. As we are in the update method, and this is called once per frame, then it's essentially going to work as a countdown timer. So let's save this. Let's go to Unity and wait for the compilation to be complete. And after that, we're going to press the play button. So we're going to see our enemy moving to the left. Once it reaches here, it's going to stop, wait 2 seconds, and move to the right. And now you can tune this waiting duration if you want. You can set it to 1, and then it's going to wait for 1 second before moving to the other side. So we have the complete, almost the complete mechanics for the rolling enemy working. Okay, let's just change that to 1. But there is one thing that we have to do. Okay, right now the enemy is not hurting our player. So what we have to do is we have to make the enemy to switch its depth position, okay, to a random value. And we have a horizontal range, so we should make a depth range. So a nice value that I can see here is something between 3. Actually, there's another way to do this, is we can define a certain range of values that can be used for the depth position of the rolling enemy. Something that I think is going to work well is to use 3 or 1 or -1 or -3. One of these 4 values should be interesting values for the enemy, okay? So it's going to be its depth. So let's work on this logic in the next video.